Hi everyone, welcome to Detangle. In this video we'll solve a question related to semiconductors. So we have a rectifier circuit here. Let's go through the question. A full wave rectifier circuit along with the output is shown in the figure. So input is given like this and we have the output taken out here. The contribution from diode 1R. So we need to figure out what is the contribution due to this diode, that is diode 1. So two things before we kick off. First one is center tapping. That is this connection that you see here. This is called center tapping. So basically what it does is, say we excite this primary winding and because of that we know that there will be a voltage or EMF induced in the secondary winding, and let that be, for example, let it be 240 volt, that is across this secondary winding there is a 240 volt induced. Now what happens when you center tap this is, this will act as a ground, this point, so that the total voltage, which is 240 volt, will be divided as 120 volt here across this and 120 volt here across this. So that is what happens when you center tap it. Okay, now why this is useful is because we know that the primary and the secondary winding will be fixed once when you design the transformer. So according to that, as per that, you will be always getting that same voltage here, that is 240 volt. But if I require, say suppose 80 volt, or in this case like 120 volt, what we can do is we can tap the voltage. That is, if you do a connection like this, if you want 120 volt, you just have to connect it exactly in the middle. Or say suppose you want 80 volt, what you can do is, since this is the output like this, so if you want 80 volt, maybe I can lower this thing and take 80 volt across this. So that's why we have center tapping or any kind of tapping. And the second one is polarity. That is, you can see two arrows marked here. So this means something, okay, and you have to be very careful when you check this out. That is, say suppose the two arrows are pointing upwards. That means if you have an input voltage like this, then the output voltage also will be in phase with the input voltage. So that will be of the same polarity. That is, if I give some voltage plus minus here at the output also you will get the polarity as plus minus. This is another way of representing the same thing. That is, instead of putting two arrows in the same direction, maybe I can put two dots here. So these two dots mean that the polarity induced will be same. But if they change the arrows, that is one is up and one is down, that means in that case the output voltage induced will be out of phase by 180 degree. That is, if you give plus minus here, you will be getting minus plus like this. So or another way to represent it is, one dot I put here, another dot if I put here, that means the polarity induced are different. So that is the second thing which you have to be careful about. So now that we know this stuff, let's see what happens in the circuit when we give a input. So first, for the positive half cycle, we know that the primary will be excited like this, plus minus. Because of that, a voltage will be induced in the secondary, which will be also plus minus. Why? Because these are in the same polarity. And you can see that the P side of this diode, let me call this diode as 2. So P side of this diode is connected to there is a positive potential at the P side of the diode. So this diode will be on, and here you can see there is a negative potential at the P side of this diode. That means this diode will be off. So since this diode is on or conducting, what happens is the induced current will flow like this in this path, and it will flow and it will come at the output. It won't go through this path. Why? Because this will be off and there won't be any conducting path here. So the entire current flow will be like this and it will come at the output. And the output also we have taken it like this. This is positive and this is negative. So we'll get a positive half cycle. So that is what is represented here. So we get this positive half cycle, and at this positive half cycle we know diode 2 is on and diode 1 is off. So that's what happens. Now for the second half cycle, that is the negative half cycle, what happens is the primary will be minus plus and it will induce a voltage in the secondary which will be also in the same polarity, minus plus, Therefore, this diode becomes on. Why? Because it is the p side is connected to positive potential and it will be in forward bias, and this diode will be in reverse bias, so this will be off. So what happens is the induced current will flow like this. It will flow through this path and it won't take this path. Why? Because this diode is off, and the entire current will flow through this, and you will be getting an output in this polarity, that is plus minus. So again you will be getting a positive half cycle here, and in this case the diode 1 is on and the diode 2 is off. So next, in the same way, what happens is for the next half cycle, which is the positive half cycle of the input, again the same thing happens, that is again we will get a positive half cycle at the output, but this time it will be due to the diode D2. Why? Because the D2 will be on, and in the same way for this D, diode D1 will be on, and the process repeats. And what we have is we get a collection of positive half cycle and all the negative half cycles removed. What they have asked is what will be the contribution due to diode 1, and we know that contribution to diode 1 is B and D, so that is when the diode 1 is on. So the correct option should be C. Now what if in this question the arrowhead here was reversed, or let it be given as the arrowhead is down. Now if we reverse this arrow here, what happens is, say suppose for the positive half cycle the induced voltage in the primary is plus minus, but the voltage induced in the secondary would be the reverse of it, which will be minus plus. Why? Because it will be 180 degree out of phase. So that is because of that this diode will be off and this diode will be on, and again the same thing happens, the current flows and we'll get a positive output voltage, but here the diode 1 is on. And in the same way, if the polarity is changing during the negative half cycle, this becomes minus plus. So here also in the secondary the induced polarity will be reverse of this, that is if it is minus plus, this should be plus minus. So when that happens, this diode will be off and this diode will be on. So what happens is the current will flow through this diode and it will contribute to the output voltage. So in this case the diode D2 will be on, and in the same way for C, this part of the output diode 1 is on, and for this part of the output diode 2 is on, which means that now the contribution due to diode 1 in this case will be A and C. So that's the difference.